first law of thermodynamics states that energy cannot be created nor destroyed, it can only change forms. Thermodynamics is simply the study of energy and its conversions. All thermodynamic quantities consist of two parts: the number, which gives you the magnitude of the change, and the sign, which tells you if it's endo or exothermic. Positive for endo, negative for exo. Internal energy is the sum of all kinetic and potential energies in a system, and it's equal to Q plus W. Q is heat and W is work. Negative work means that energy is flowing out of the system, so the system does work on the surroundings. It's exothermic. To help you remember that, you have system and you have surroundings. If energy is flowing from the system to the surroundings, it's flowing out, making it exothermic. So system to surroundings, exothermic, work is negative. Positive work is when energy flows into the system, so the surroundings do work on the system. So surroundings are doing work into the system, so it's flowing in. It's endothermic or positive work. So we're going to calculate the change of energy when we know the heat and the work. So first, we need to figure out if heat is endo or exothermic. Our heat, or Q, has to be positive 15.6 because it says it's endothermic. So that's positive. While work is being done on the system. So it's being done on the system, so it's going in, which is endothermic. So it's a positive 1.4 kilojoules. So plugging it into your equation, you're just going to add them up. Giving you 17.0 kilojoules. Go ahead and solve A on your own. Restart when you have it. We need to calculate delta E, so we need to write our equation. Heat, it says that it absorbs 85 kilojoules, so that's positive or endothermic. And work, it says the surroundings do work, or the system does work on the surroundings. So if the system's doing work on the surroundings, then that has to be exothermic or negative 29 kilojoules. Adding those up, you get 56 kilojoules. It also says to determine if it's endo or exothermic. Because my delta E is positive, it's overall endothermic. Go ahead and pause the video and try B on your own. Q, it releases 57.5 kilojoules, which makes it exothermic or negative. And work, it says that the work is done on the surroundings. So systems doing work on the surroundings, making it exo or negative as well. Add those up, and you get negative 71 kilojoules. And it's overall negative, so that means delta E is exothermic. Go ahead and pause the video and try this one on your own. This problem was slightly different because they gave you heat and delta E, and we're looking for our work. Delta E was 1.64 kilojoules. Our Q, it absorbs 2.17 kilojoules, so that's positive, and we're looking for work. Plug it into our equation, and solving for x, you get x to be negative 0.53. Because work is negative, then that means the system must be doing work on the surroundings. So the only answer that could possibly be is A. B would be the answer if it was positive 0.53. And C and D, you just solved it algebraically incorrectly. Go ahead and classify these as endo or exothermic, and we'll go over them in class. For gases, work is equal to negative P delta V. If gas is compressed, then volume will be negative since the volume decreases. Delta V is always equal to final volume minus initial volume. If volume is negative, negative times negative makes it a positive, and so that's why work will be positive when a gas is compressed. When a gas is expanded, then the volume will be positive, and so work will be negative. So we need to calculate the work associated with the expansion of a gas from 46 to 64 liters at a pressure of 15 atm. We write down our equation. And our volume is equal to 64 minus 46, or 18 liters. Pressure is 15 atm. Don't forget your negative sign when you multiply them. And that gives you negative 270. The units are liters times atmospheres. Go ahead and pause the video and try doing this one on your own. Restart when you have the answer. You're looking for the change in energy, which means we're going to have to use our delta E equals Q plus W. But they didn't give us work, so we're going to have to calculate that using the equation we just learned, negative P delta V. So first, I'm going to solve for my work. So my change in volume is 500,000 liters. Pressure was 1 atm. So solving for work, you get negative 500,000 liters times atmospheres. We need to convert that to joules though. They gave you the conversion. So that's negative 5.065 times 10 to the 7th joules. We needed our work to be in joules because our energy is in joules, and we're going to add those up. It says we added 1.3 times 10 to the 8th energy as heat, so that's positive. So now we're just going to add our heat and work together. That gives you 7.9 times 10 to the 7th joules. So pay attention to your units and make sure that they're going to cancel out. And overall, this process was endothermic since delta E was positive. Go ahead and pause the video and try this one on your own. You should have gotten B as in boy. If you did, then you can stop the video. If not, keep going and see how we got B. We're looking for work, and so our work is equal to negative P delta V. We need to have our volume, and that's 189 minus 152. Which gives you 37 liters. Pressure is equal to 14 atm. So work is equal to negative 518 liters times atmospheres. We need to have our answer in 2 sig figs, and that's why the answer was B.